Okay, this video is going to cover how we might some basics of trig functions. We have two similar triangles here. They're similar because their angles are congruent and their sides are proportional. You see they're marked congruent here, and 3 is to 6, as 4 is to 8, and 5 is to 10. So in these similar triangles, we're going to find the sine of angle B. Now remember that sine is the opposite over the hypotenuse. So if you are situated at B and you want to know which one is the opposite, it's the one that doesn't touch you. This is your hypotenuse, this is your adjacent, and this is your opposite. So the opposite is 3 and the hypotenuse is 5. Now you might be asked to convert that to 10,000ths of a place. It's going to be 0.6. In trig, they'll like to go 4 decimal places. Of course, this ratio doesn't have anything behind there, but you could fill in with zeros if you needed to. Now we'll find the sine from B prime. If you are situated at B prime, this is your opposite. This is your adjacent, and this is your hypotenuse. So this ratio is opposite of 6, hypotenuse of 10, which again is 0.6 or 6/10, any way you look at it. Now, there's a pretty neat thing. These trig ratios are the same no matter the length of the sides of the triangle. Obviously, the 3, 4, 5 has shorter sides than the 6, 8, 10. It's not the side lengths, it's their relationship. Both of these triangles, because they have congruent angles, have the same relationship or the same ratio. So if you took this bigger and you made it even larger, say you made it 12, 16, and 20, you would still get the same ratio. And what it depends on is not the length of the legs, but the size of the angle. So it's not necessarily how big the door is, if you think of this as a door that opens and closes, but it's how much the door is open. Now, if you want to find the actual measure of angle B, that's what trig's really used for, is if we know these lengths, we can find this angle, or maybe we know the angle, we can find a missing length. On your calculator, if you know the ratio, or if you know the decimal equivalent of your sine, cosine, or tangent, you can find the actual measure of the angle. Now go to mode. We're going to work in degrees because you really are pretty safe in degrees until you get into actual trigonometry. So I'm going to make sure it's in degree mode. Calculators don't default to degree mode. They default to radians. So now that I'm in degree mode, I'm going to press second, sine, because that's the one I know. I know the sine is 3/5. So if you know what the sine is, you do second sine. That's like saying sine inverse, meaning I know what the sine is, I just don't know the angle. And you hit enter, and it gives you this, and we're going to round it to 2 decimal places. So we're going to call that 36.87 degrees. Now I'm going to do the same thing for the next one. Obviously, I'm going to get the same answer because we know that that's the same ratio. Same exact answer. What if I had put it, put it in as a decimal? Same exact answer, 36.87. Now, caution. I don't want you to do this. I just want you to be cautioned. If you're in radians and you put this in, it's going to give you an answer, but it's going to be it's not going to be accurate at all. So please be sure you check your mode when you are dealing with trig. Now, some problems that we might be needing to practice on. Find the value of each trig ratio to the nearest 10,000ths. And they want the tangent of angle A. So the first thing I would do is I would put my smiley face at A. This is the hypotenuse. This is the opposite side. And this is the adjacent side. Now, for tangent, I need the opposite over the adjacent. So that would mean the opposite of A is 30. The adjacent side is 16. And then they want me to give their answer to the nearest 10,000th. So 30 divided by 16 is 1.875. Now that's the tenths, that's the hundredths, that's the thousandths. The 10,000th place is 0 on this problem. Number 2 asks you for the cosine from angle C. So I'm going to put smiley here. This is my opposite side. This is my adjacent side. That's my hypotenuse. Cosine deals with adjacent over hypotenuse. So the cosine of C is 12 over 15. Now you could reduce that, but they want me to give it to them in nearest decimal form, 0.8. Fill in with zeros because they want it to be to the 4th decimal place. Sine of Z. There's Z. This is your opposite. This is your adjacent. This is your hypotenuse. And we know that the sine is the opposite over the hypotenuse. So that's going to be the sine of Z is going to be opposite, which is 12, over hypotenuse, which is 20.6. Okay? Now, all of these aren't going to end up being such nice decimals. Most of the time our decimals are different things. But this is just to get us started. This is just to help us kind of get started on finding these trig ratios. One more thing I wanted to add to this is that you can use the calculator to find the value if you know the angle. So easy, so very easy. Make sure again that your calculator is in degree mode and then just type in sine 21. Now if you know the angle, you don't hit second sine. That's only when you know the ratio or the decimal equivalent. If you know the degrees, you just hit sine of 21. It's going to give you this number. Now they want you to report that number to the nearest 10,000th. So that's 0.3584. Okay, and the next one says tangent of 22. That's going to be 0.4040. So this is super easy for you to do for these trig functions.